Hello and welcome to this Aimsun webinar explaining the new Aimsun Next viewer, which has been designed to help you continue to work efficiently and effectively during the extensive home working that we're experiencing at the moment. My name's Paul Hutton. I'm your moderator for today's webinar. We're going to have a brief presentation and demonstration before taking your questions. So let's now cross to Aimsun's headquarters city of Barcelona and welcome Dimitris Triantafyllos, who is Senior Product Specialist at Aimsun, who will explain all you need to know about the Aimsun Next viewer. So if Dimitris, you want to unmute your microphone and join us from the beautiful city of Barcelona, the floor is yours, sir.
Hello, Paul. Thank you for the short introduction. It is a pleasure to be here, virtually here with you. Hello to everyone. I would like to welcome you in today's webinar session. Today, I will try to walk you through the new Aimsun Next license type, the so-called Aimsun Next viewer. But let's see what the Aimsun Next viewer stands for. The viewer is a new tool for a remote third party to replay a recorded simulation or retrieve data from a previous execution of any Aimsun Next model. Everyone who has ever been involved in any transportation project could easily understand that building an accurate transportation model is not a simple process. Coordination among different parties and teams is always necessary. So, on one side, the transport modeler builds a model based on project specifications. On the other side, the project manager waits to see progress. And finally, the client is waiting for mid-term or final deliveries that go along with the initial plan of the project. In every project, the project manager needs to have a continuous supervision over the accomplished, pending, and future tasks. The end client needs to be in a communication with the project managers and receive midterm results or any simulation reports. This is exactly the aim of the viewer, to make communication easier and more transparent among different teams involved in a project. Therefore, even non-modelers will find the viewer easy to operate. In addition, please note that since there is no need to make any changes on the Aimsun model, editing is not allowed. Who is it for then? The viewer is for people involved in a project who need to review model outputs remotely but do not have access to Aimsun Next software. Using the viewer license, the user would be able to share the Aimsun files and databases with any authorized third party and present the work in progress or even the final results inside the Aimsun Next environment. By holding a viewer license, the project manager will be able to review model inputs and outputs, even if he doesn't have access to the Aimsun Next modeling software. The end client will be able to explore the model outputs and statistical results with transparency if needed. Who can request it? Any transport modeler who is an owner of an Aimsun Next license with active subscription will be able to generate a viewer license and share with the client his work. Let's now have a closer look at the Aimsun Next viewer features. First of all, the user should open the Aimsun Next document, the ANG file, using the Aimsun Next viewer software. To do so, he will need to find the ANG file sent by the transport modeler in his working directory. In this case, we have an example with the ANG file called barcelona.ang. And then launch the Aimsun Next viewer software and of course open the ANG file. Another feature of the Aimsun Next viewer is that the user can retrieve results from a database. In this example, we have created a barcelona.sqlite type database, and the simulations that can be retrieved can be either static or dynamic. He will be able to retrieve Aimsun path assignment files, but first he will need to search for files with an .apa file extension. And finally, he will be able to retrieve traffic measurement detector data by reading a real dataset external file. Another feature of the Aimsun Next viewer is that the user will be able to play a recorded simulation generated previously from a dynamic simulation, either microscopic, mesoscopic, or hybrid. Simulating with the Aimsun Next, the trajectories of the vehicles are saved in a .arf file. Search for these files in a file that has been sent to you, which is called rec_replication_id.arf. That replication ID file should match with the one of the simulated replication in the model. So the main advantage of having a play recorded simulation feature is that it allows the simulation to be reviewed in order to examine vehicle behavior in detail. Another feature of the Aimsun Next viewer is that allows the user to apply predefined 2D view modes, which are basically maps that visualize simulation results of several objects. On the right side, you can see the delay statistical outputs per sections that are being visualized. Also, the user will be able to further analyze the node outputs using the detailed node view. On the left side, you can see a screenshot where the volume over capacity of the input links is analyzed. The user will be also able to hide or reveal dynamic labels by the click of the button. He will be also able to open print layouts which have been predefined by the Aimsun Next user and show the layout with the results. You can make use of the time series viewer to compare different simulation scenarios or statistical outputs of different objects of the same type. For example, sections, turns, groupings, etc. You will be able to visualize space-time diagrams for existing detector sets. Open 2D view or 3D view modes and select one camera from the list from the drop-down menu. The user will be also able to select predefined static or dynamic bookmarks. He will be able to select an active experiment to see the effects of geometry configurations and attribute overrides. We will see a live example shortly in the live demonstration that will follow. He will be able to filter the view by subnetworks by just right-clicking on the UI of the Aimsun Next viewer and select the filter option. And finally, he will be able to open in Google Maps the current view selected in the Aimsun Next UI with just the press of a button. Let's now get to know some more of the basic features of the Aimsun Next viewer with this live demonstration. I'm sharing now the Aimsun Next viewer software. Once you have filled in the form, in the contact form that we will show later on, you will receive an installer. Both you and the client. So once the installation process is complete, then you will find a shortcut on your desktop of the Aimsun Next viewer. By double-clicking on the Aimsun Next viewer shortcut, you can open the Aimsun Next software. This is the first window of the Aimsun Next viewer software. Once you, prior to the opening of the ANG file, the user can check the preferences selected by the Aimsun Next user. So please go on the, we can go to the view edit, preferences, and open the system preferences editor where the viewer user can have a look of the parameters chosen by the transport modeler. Of course, no editing options are allowed, so there's no OK button and only cancel button. Also, you can check the latest, from this window, you can check the latest Aimsun news posted on the social media and in our webpage. By scrolling down, you can see all the latest news of the Aimsun Next software, also the training calendar, and so on. So now, if a network has been previously opened via the viewer, there are more options available to open that network. So you can just go on the file, on the menu bar, and see the option recent files, where you can find a list with the previously open networks. Or you can just go on the main window screen and see under the projects tab the list of the networks that have been opened during the past weeks. If it is the first time you open this network, then navigate to the menu bar, click File, Open, and search for the network that has been sent to you by the client. In our case, it is the Barcelona.amg network. I will open that network. This is the model of the central area of Barcelona, which is called a sampler. In this demonstration, we have created a subnetwork where you can see it with the red dot lines, red dot polygon, displayed, and the macro simulation area that represents the calle, the street Valencia, which goes with the northeast traffic direction. The aim of this example is to retrieve statistical results from macro, meso, micro, and hybrid simulation runs. The scenario to compare with the do-nothing scenario refers to the transformation of the streets for two entire blocks from vehicular traffic usage to only pedestrian usage. This scenario is also realistic and is being called superblock. It has been addressed from the Barcelona municipality some years ago, and we hope to see that implemented soon. So first of all, under the project folder, in the scenarios tab, I can see that I have we have one static assignment scenario, and we will try to retrieve the results of this simulation. Right-click on the static assignment experiment. I will see the option Retrieve Static Traffic Assignment Results. So with a click of a button, I can see that I have retrieved the assigned values and all the statistical results for this macroscopic static assignment. Then I will go to the experiment and retrieve also the static path assignment results. I'll open the static assignment experiment, and here I can see the input parameters defined by the transport modeler, various tabs with various options that can be explained by the transport modeler to the Aimsun Next viewer user. So in the Outputs tab, we will be able to see simulation results for persection, turns, connection, supernode trajectories, and of course, validate. In this case, we have no data to validate for this static assignment. Also, by retrieving the path assignment results, I will be able to see the path assignment tab, which represents the window that the Aimsun Next viewer user can analyze all the paths that have been generated by this simulation. So by just clicking on the List Paths option, I will see shortly all the paths generated from its origin to its destination. So by randomly clicking on one set of paths, I can see that I can visualize easily with colors the paths generated with the percentages and the probability and the vehicles generated from this origin to that destination. Other options are also available, distance and cost. And here on the upper part of the window, I can only see the filter options that I can filter per OD pair or entrance section, exit section, any section that this path is assigned, and of course a number of vehicles generated that I can filter as well. Last but not least, I can also have a link analysis of several paths or for the whole set of paths generated from this simulation. I will cancel that. So, however, the transport modeler has sent us instructions that the study area has been simulated using a subnetwork. So press right click anywhere on the UI and select filters. I will first of all quit the view mode that has been automatically generated, and I will go on the UI, press right button, and then select the subnetwork. Using that filter option, we can just isolate the study area. So now let's go on the subnetwork folder and find the centroid configuration, where we can activate that centroid configuration that represents the OD pairs for this subnetwork. Let's now retrieve the following simulation results of a static OD adjustment that was executed to adjust the input OD matrices, scenarios, static adjustment. I can always double click on the scenario and see all the input parameters: demand, transit plan, real data set, master control plan, and other parameters set for this static adjustment process. And then I will right click on the experiment and I will retrieve the static OD adjustment results. Before I get to compare the results and see the validation tab, I will need to check on the scenario which real data set has been used for this adjustment process of my OD matrix. So here I see that the detection data that have been used is a real data set. I will then go to the folder which is called data analysis and search for the real data set folder and retrieve my detector data. Then I will double click on the experiment of the static OD adjustment, go in the outputs, on the validation tab, in the final assignment outputs, on the validation tab, and see my validation result. Right? Another option that I have here is to retrieve the path assignment results. So by just right click on the adjustment experiment, I can retrieve the path assignment results, and on the log window, successfully I can see that the path file has been loaded. Then I'll retrieve the static OD departure adjustment results, a process that was executed to profile the adjusted demand in time intervals of 15 minutes, and then, of course, I'll check the results. I'll open, right click on the departure OD adjustment results, and double click on the experiment, go to check the inputs and the outputs. So first I will check the outputs, and here I can see how my OD matrix, which was of 1 hour, has been profiled into 15-minute intervals, and I can see the validation of the adjusted volumes of these OD matrices to the detection data. So here I can select each time interval and see the validation result of this departure OD adjustment process. Next step is to retrieve a dynamic user equilibrium mesoscopic assignment for the base scenario. So in the base scenario, I will see that I have a scenario, an experiment, and the result of the DOE assignment. Right click on the result of the DOE and retrieve the replication data. Then I can always check, as I said, the inputs for this simulation that are defined in the main tab in the scenario, which outputs have been chosen by the transport modeler to be exported, Aimsun Next APIs, the strategies that have been activated, and also in the experiment, some more parameters of the models that have been defined for the car following model, for reaction time, arrivals, and some more parameters in terms of the dynamic traffic assignment process. Now I'll double click on the result of the DOE, and I'll head to the validation tab to see my result. Then I have, after running a meso dynamic user equilibrium for my subnetwork area, then the purpose of this project is to simulate the hybrid network of mesoscopic for the whole red area and microscopic for the microsimulation area, which is here drawn with a pink color. So I have created another the transport modeler has created another dynamic hybrid scenario, and I can retrieve the replication data for this hybrid scenario. I can always, as I said before, check all the input and output parameters, and I will double click on the replication of the hybrid base scenario and go in the validation and see my result. I can also see the result per 15 minutes and go and calibrate several parameters locally or globally. Not calibrate, suggest to the transport modeler which parameters should be further calibrated. And then last step is to retrieve the simulation results of my scenario, which is the superblock scenario. So I will right click and retrieve simulation results. So now we've seen how from an entire network we were able to retrieve static assignment outputs, not only the results, but also the path assignment files. And then we moved down to the subnetwork, which is the red dot polygon. And we were able to run a static, we were able to retrieve results from a static adjustment, a static OD departure adjustment, a DOE experiment, a hybrid scenario, and a superblock hybrid scenario to compare results with the normal, with the do-nothing conditions. Now it is time to play a recorded dynamic simulation and see the results. Let's play first for the DOE. So we can go to the result, right click, and find the option play recorded simulation. Once I click on play recorded simulation, on the upper part of the Aimsun Next viewer, I can see the simulation control window appearing. So the simulation control allows the user to play the simulation. So I will zoom in so that I can see small entities running throughout the network. I will change the view mode for better visualization. So here I can see the last iteration of the dynamic user equilibrium. So I can pause the simulation. I will be able, as an Aimsun Next viewer, to step forward, step backward the simulation, fast forward the simulation by pressing this button, and fast backward the simulation. Also, I will be able to define the smoothness, the speed, sorry, of the simulation. And also the last option is restart the simulation. For the DOE mesoscopic assignment, the feature play recorded simulation saves the trajectories of the vehicles in a .arf file. So the transport modeler has already run the simulation, and he has clicked the option to save the trajectories in a .arf file, so that the viewer user can later retrieve these statistical results and see the simulation running, the recorded simulation running. So the trajectories saved regard to the results of the last DOE iteration in this case. So as we, most of us know, the DOE simulation consists of several iterations. The last iteration, we are saving the statistical outputs and also the global outputs and also the play recorded simulation outputs. We have to verify that the replication ID of this result, which is here, matches to the replication ID which is in in the file sent by the transport modeler. As I said before in my presentation, we expect to see a file which is named as rec underscore replication ID, which should be that ID, so that the simulation can be easily retrieved by the .arf file. Not to forget something which is really important is that the mesoscopic simulator is a non-discrete simulation, but an event-based simulation. This means that the simplified models of we have simplified models of the car following, lane changing, and gap acceptance. And therefore, the agents displayed are just approximations of vehicles entering and exiting each link based on the simulation statistics. On the other hand, while we're running a microscopic simulation and we're saving the trajectories in a .arf file, the microscopic simulation is a discrete simulation, so the position and the speed of the vehicles is represented as in the original simulation. Let's now stop this simulation and go to the hybrid base scenario and play recorded simulation for the hybrid scenario. So in this case, we can see the simulation is consists of two different agents. The ones outside the pink area, which is the microsimulation area, are small circles, which are representing the entities simulation results of the mesoscopic assignment. And inside the pink area, we can see vehicles, normal vehicles of the microsimulation, of the Aimsun microsimulation software, which represent the vehicles, the trajectories of these vehicles, of the simulation run by the transport modeler. The advantages of play recorded simulation is that it allows the user to revisit any part of the simulation without have to rerun that replication. So this is really important for maybe some project managers that they would like to see a specific gridlock or a specific blockage, congestion point that the transport modeler is trying to reproduce with his model. I will cancel now the recorded simulation, and I will change a little bit the topic and go to check the view modes. Let's now have a look on the view modes, which are visualization maps of the simulation results. I'll first apply the default view mode of the simulated delay time. So I will go on the upper part of the Aimsun window and search for the simulated delay time view mode, which is a default view mode of the Aimsun Next software. So here I can see that I have activated the hybrid base scenario experiment and the replication of the hybrid base. The view mode that I'm visualizing is the simulated delay time, and I can just select play and see how the statistical interval that has been set to 1 minute is showing me the progress of that simulation along the time. This is another way of replaying the simulation on a global scale and see results. Okay, then I'll select the hybrid superblock scenario on the top left corner. So here I will select the superblock. There is only one replication, and I can see the difference between the two simulations. Then I'll apply the view mode that is the transport modeler has created, and it's called VM Superblock. which shows the streets in the heart of the sampler that that will be converted to pathways for only environmental friendly modes of transport. So as a consequence of this measure, no vehicles will be able to run through these sections. Then, apart from this view mode, there is another view mode that the transport modeler has created to show to the manager that not only this feature, but also the neighboring sections will have a reduced speed compared to the rest of the network. So I will visualize the maximum speed of the sections that have 30 kilometers per hour. So I can see that here, this area that has been converted from traffic usage area to pedestrian and more friendly environmental friendly modes of transportation. I can see also the surrounding sections that have been chosen to have a speed limit of 30 kilometers per hour, a traffic calming measure. So I will just deactivate the view mode, and finally I'll open a node and go to the detail node view tab. So I will go to that node, double click on it, search for the detailed view, and here I will switch the attribute to flow, and I can see, for example, for the DOE scenario, how the flow, I can see that I have created two color view style for sections and turns, and here I can analyze further the results, or the simulation results for this specific location. Input links, basically. And I can also play the simulation from here and see the colors changing. All right, I will close now that window. I see how a user can analyze globally and locally via the view modes, the simulation results that have been sent by the client, by the transport modeler. And then another option that we have is that the viewer user can check, for example, already predefined dynamic labels. So if I play the simulation here, I can see that the delay time that I have set here as a dynamic label is evolving every 1 minute for this specific link. And then there is also the option to activate and deactivate. So here it is activated, and I can easily just press show dynamic labels deactivation, and this dynamic label will disappear. Another option, as I mentioned in my presentation, is the print layout. So the user will be able, the viewer user will be able to open the print layouts that the transport modeler has created. Here I can see that the delay time is being showed, but first I would need to go to the view mode, select the view mode simulated delay time, maybe for the aggregated, select the base scenario, and click on the print layout and see the simulation result. So this is something that maybe the transport modeler would like for the project manager to have another look, because maybe this print layout is about to be inserted in the final report. And you can, of course, it can be created much more print layouts than the one that I have shown in my example. Another option is the time series viewer. We can make use of the time series viewer to compare simulation results, as well as the data comparison. So we will see now the time series viewer. We want to compare global simulation results for the base scenario and the superblock scenario. So I will just press on the replication once and add series of the delay time. I select here the statistical outputs that I would like to compare, and I add series. Then I will select another replication, which is the superblock scenario, and I will add series with a different color this time. So it is obvious that in the superblock scenario, where we have implemented the traffic calming measures for the city center of Barcelona, we'll see that further measurements are necessary because we see that the delay time has a significant increase during the whole time of the simulation. More options here that the viewer user can use is the auto scale, for example, or he can show value labels, and of course on the upper left corner of the screen of the window, we can just show we can switch from the 2D line graph to a histogram with the global values. And another option is to show the location in Google Maps. So if I would like to see, let's say on specific location, a node or the whole area in Google Maps to analyze further maybe the geometry of my network, because the viewer user may have some doubts about some geometry that has been coded in the transportation model with the Aimsun Next software, then he can just open on the menu bar the show location in Google Maps feature, and that will drive him directly to the location of that intersection, for example. Another option that the viewer user would be able to check is the 3D. So he can open a new 3D view or another new two-dimensional view. So if I open now a new 3D view window, this takes some time.
Dimitris, while this is loading, I'll just ask one question that's come in during the presentation you've been giving. One viewer has asked what a superblock scenario is. So if you could explain that while this is loading, that would be great.
Okay. Well, the superblock scenario is just an idea of the Barcelona municipality to convert several blocks, as we can see in the Sampla area, in the central area of Barcelona, several blocks to pedestrian islands. This is how they are called. So they will try to convert blocks of streets from vehicular traffic to pedestrian usage. This, of course, is was a plan for the future that maybe now will be accelerated since we're living all this situation with COVID-19, and many cities have been accelerating plans that were under discussion or under evaluation for the future.
Okay, thank you.
So here we can see in the Aimsun Next viewer software the 3D visualization that is working as well. It's a bit slow in my computer. I'm running many stuff right now, so I will close that 3D view. And the last feature that I would like to show you for today, a live presentation, is the geometry configurations and attribute overrides. So this is how we can further explain what is the superblock scenario. So I can switch between the base and superblock scenario here. I can select the VM superblock. So here I can see that this area of Barcelona, a sampler area, has been converted from traffic oriented to pedestrian oriented usage. So to make this happen, the transport modeler had to create another object, which is, in my case, is called geometry configuration object, and create to maintain the geometry of both implementations in one model, in one file. Then we are able, as transport modeler users, to create geometry configurations. This means that for one specific scenario here, I can select to activate this geometry configuration superblock. So first of all, I have to create sections. I have to create the new geometry on top of these sections, and then I can select in my geometry configuration object which sections I would like to show and which sections I would like to hide. So here it is like a mirror. I can see that I would like to see existing sections only these ones, and not existence that ones. So it would be much more visible if I was creating two geometries. One would be a four-arm junction, and the other one would be a roundabout. So I could switch from an intersection to a roundabout and have both geometries in one network file assigned to different scenarios. This is the usage of the geometry configuration tool to maintain as many geometries in one file, in one Aimsun file, without having to duplicate and making different ANG files. So here I can see that the geometry configurations are also visible, and also for the area or the surrounding area of that implementation, that the speed limit has been changed from 50 kilometers per hour to 30 kilometers per hour. I have created an attribute override object. This object is able to override parameters, any parameter of any object in the network, and override it for a specific simulation. So I create a new attribute override object. I select the sections. I set the new value that I would like for a specific attribute, and then I go to the scenario. On the main, I can select the attribute override to be implemented. So also this option is available, and I can see that modification by just swapping from the base to the superblock scenario. All right, I think that was all for the live demonstration.
Okay, that's terrific. Thank you very much, Dimitris. So we're going to have some questions now, and we've got several coming in on the chat. Dimitris, I've just got a couple of questions for you first, though. How do I get the viewer, and how long can I use it for, please?
How do I get the viewer? Here is the answer. In our website, you will find two different contact forms to submit. One form with your data, and another form for the person who needs the viewer. So once done, Aimsun will send the installation guide for a quick and easy setup in just 2 steps to both of you. There is no limit in the registration for the viewer, so you can submit an unlimited number of forms per client or per manager.
Right, that's all we've got time for, Dimitris. So thank you very, very much for that very comprehensive explanation of the Aimsun Next viewer and its capabilities. If you have any further questions, do please get in touch, and we'll do our best to answer them for you. And we'll do our best to help you in your work to redesign transport, at least in the short term. Remember, Aimsun is here to help. So I'm going to ask Dimitris just to, on his screen, just show on the page on his presentation the link to go to the viewer. And so then you can see where to go for the viewer and to register to have that viewer. And I'll leave that on the screen. But for now, thank you very much for watching this this webinar from Aimsun. Thank you very much, and we'll speak to you again soon.